Welcome everybody today to new features in RISA. As Amber mentioned, we're going to be talking about RISA 3D version 12.0, RISAFloor version 8.0, and RISAFoundation version 6.0. These were recently released, and if you're not familiar with our release schedule here, we release about once a year, at least sometimes more than that, but we'll see here that this version came out. This is a major version release, and so we're going to be seeing all the new features that went into there. If you're under maintenance with us, you might have also gotten an email notice that this has come out, and you can download that. If you haven't, feel free to contact us after the webinar. So let's see here. One of the big features we're going to talk about is RISA 3D. Starting out here, the envelope with batch solution. Let me kind of explain what this means a little bit. Starting out with the envelope solution, if we talk about what that is, the envelope solution runs all the load combinations, and what gets reported back to you upon solution in RISA 3D is the worst case results, which means that you're finding the minimum and maximum on the joint reactions, the deflections, the design results. Everything you're seeing there is based on the minimums and maximums of what got run in that entire load combination selection group. So it's a smaller solution file often because you're just looking at those basically two values for each member or for each joint, minimum and maximum. And you can see that solution file. And a lot of times in larger models, people would run the envelope design, envelope solution, find their design, minimums and max, worst case, and then save that. But behind the scenes, really, we are running the batch solution. So the batch solution is where you're running each single load combination, and you're saving those results for each single load combination. So the way we did that to go forward is this new feature was to combine the two. Now solve them both at the very same time, and that way you get results for both. This may seem kind of minor if you're looking at a beam model, but if you're looking at a large-scale model, something that takes a little while for you to run with thousands of members, this combination of the two is really useful. And we'll see an example of how that works together and how that might be very useful for you to use and design. Like I said, we'll see examples of this. For all of the features I'm going to show you, I'm going to actually give you some examples. We'll open up some models and have some examples of what we're doing. The next one I want to show you is for all three programs, RISA 3D, RISAFloor, and RISAFoundation. It went into every program that we improved the report printing. So you'll see that we added a lot of new features, including adding the company logo. So you can put your logo on the top left corner of the report. You can include images. So any type of image you want, you can include that, be it from something within the program. And I'll show you how to collect those images inside of the program. There's going to be a little camera signal, and we're going to be able to collect all the images you might want to see, as well as detail reports. And then basically you can put in your report a PDF, PNG, or JPEG, any of those three. Now the PDF is the most powerful. If you think about it, really anything can be printed out to PDF. So if you can print it to PDF, you can put it in your report, and we can combine it all together and number it and have it work together in one giant report, which is helpful, especially if you're putting a calc package together. So I'll show you that in RISA 3D, an example of that going forward. The next thing I want to show you is the moving loads. So we really worked on moving loads. This is a great way, if you're not familiar with what a moving load is, I'll show you how to apply a moving load here coming up, but it's basically going to allow us to put a group of loads across a structure. I'm showing kind of a rail here with two different types of load, actually 3-point loads that are moving across it. And we added some other things into the program where we added the AREMA railway loading into our database of library of different moving loads that we have. So that was added in. We also added the ability to see the load animation step by step. So when we've in the past, you can see the animation. It's really powerful to be able to see how the loads are coming across your structure. But what also now is that you can slow that down and see it at a stepwise. So what we call that is increments or steps, and we can apply the increment that we want to be looking at. So for example, this might be a couple hundred increments along the member that we're looking below there, and we can look exactly at that increment. Now, the last piece kind of ties that in is that we'll give you the maximum load location in the report. So we'll be reporting where the maximum location was of that increment as step-by-step location, and then we can see it visually. So I'll combine those together too, and when we see that example, it might be a little bit better to see that in action. So The next feature I want to show you guys is the dome. We added a geodesic dome generator to our high-level generation tool. So if you're familiar with the high-level generation tool, this is a template that you can put together any type of a structure, but this one in particular is a dome, which is pretty difficult to accomplish on your own. Plates in particular are difficult when they go on these different angles, but then also creating it with all these members, you can end up a lot of times with coplanar plates and things like that. So this is a great starting point for a dome, and it does that automatically for you, plates and members. And so I'll show you a demonstration of that. The next piece I wanted to show you guys was in RISA 3D and RISAFloor, and this is enhancing the member design rules. So what we did is we added a graphical interface so that you can really see what the design rule that you're laying out with the minimum depth and the maximum depth here and width. You can define that. You can also define your bending check. But really where it comes in usefully is for the reinforcement. If you look to the bottom right corner, you see here I have a picture of the screenshot, and it shows me that I can put the reinforcement, what my bar size are, what my cover is, and sometimes that's easy just to see, but it's better to see it in a picture. And so you can do that for a beam or for a column, and it will show you here how you lay out the reinforcement. You can also lay it out explicitly using this design rule, so it's a little bit easier to get an explicit layout versus trying to spell it out in an old-fashioned way. So we've got the next one here I want to show you a little bit about is trim and extend. This is a modeling tool that we've added to both RISA 3D and RISAFloor. And this picture here is just a picture showing you a RISAFloor and how we might have a geometry. I showed on the top where you have it a little too long, these beams, and on the bottom you have them a little too short. And in RISAFloor, the way you would have fixed this might be to move those nodes, those endpoint nodes, but it's kind of difficult to know where they're going to land on that beam. So one of the things we added was this trim and extend, and we'll see that I'll show you in action how to use it, but what it's going to really do is it's going to extend those members, and with just 2 clicks, I'm going to be able to extend them directly to the diagonal member. And then I'm also going to be able to trim them back on the top portion here. So it's really fast and easy to modify your model. And this works both in RISA 3D and RISAFloor. So if you ever had to work modifying your model with our RISA 3D and Floor, and this one both, it's hard to kind of really know which one is a better tool in each, but I think for framing, trimming is really good. For RISA 3D, if you ever have to work a truss out, things like that where you couldn't quite get a grasp where to land that member onto the member, that's a perfect tool in there too. So we'll use that and see how that works. In RISAFloor, we have added Outriggers. So you can apply an outrigger to anywhere from a column in any angle. Previously, we had cantilevers, and a cantilever required that you had a backspan. But we'll see here you can draw those outriggers at any angle. You can draw them at any material, so they actually don't have to be the same exact material. They don't have to be the same exact shape. So this is a wide flange picture I'm showing, but this could be a tube coming out. This could be an angle, whatever you needed it to be there. So it gives you a lot more flexibility for using outriggers than cantilevers. In RISAFoundation, in particular, you've got a material takeoff that we've added there. So this will give you a similar to what we see in other RISA 3D and RISAFloor. This is like that, where you get each material specified, giving you an itemized list. So the slabs, the beams, the footings, the pedestals, all that's listed out for you with the volume and the weight. And this is great for kind of just a total number of how much concrete went into the project, things like that. And for whatever you might need to your material takeoff. But I think one of the best ways to see is how much weight you have in the structure. So what I do want to show you is kind of jump in and use the program a little bit. That's the best way for you to see it. So let me open up RISA 3D, for example, here. And in this model, I want to demonstrate that moving loads tool. So starting before we even get into the moving loads, I'm going to make a couple modifications to the model so you can kind of see how we worked with some of those trim and extend tools. So this is just I'm looking at this in isometric view, and you'll just see it's a frame. As we're moving, we look at this in plan view. It's just a rail, and I want to make this 2 rails versus 1 rail, moving over several frames, and we're going to apply a moving load that goes across those frames. So what I'll do is I'm going to copy this. First thing I'm going to do is just copy this one long beam here, and I'm going to use my copy tool. Everybody should be familiar, if you're familiar with RISA 3D, with the copy tool. It's changed a little bit over the years, but you'll see I'm just going to use the Z direction, maybe just go in -2 direction, which means I'm moving to the left of my screen, the negative direction. I'm going to say apply it to the member, and it'll copy that for me. So that's pretty simple, and you should all be familiar with that. But I'm going to also do this here. I'm going to try to do this on these diagonal members, which is a little bit harder because they are on a diagonal. I can't just say move in the global Z direction. I think this is about last version that offset got added, so I can use this tool. And the copy offset would really help us if we were going to copy this in the local axis. So I'm looking at the Z direction is probably a helpful way to use this. So if I click on the copy offset, I see that it's going to copy this. It's going to label the joints and the members for me automatically. And I'm going to use this in the -2 direction. And instead of globally, I'm going to use the local offset, so in the local Z direction. And I could just click on that, and it will copy offset it in that direction. I'm going to do the same thing to that member on the next one. So I'm going to say -2, and I'm going to apply that to this one right here. So now let's look back on this in plan view, and we see, okay, so now we've got some members that are copy offsetted, but they don't quite meet up with our members that we need. So I'm going to turn my local axis off, and because it's a little distracting. But what I am going to do now is use my trim and extend tool. So these are actually extending. That's what I'm using here. So I'm going to click on this button right here. It says Trim, Extend, Crossing Members. And there's either a trim option or an extend option. I'm going to pick the extend option. My mouse changes, and then I just click on the member that I want to extend, and then I click on a member that I want to extend it to, or what I call the boundary member, and then it goes right, extends it to it. So I'm going to do the same thing here on the next one. I'm going to extend this to this member, and I'm going to extend this one to this member. And now we get everything snapped together. So at that point, if we look at this nice symmetric view, I have now 2 nice rails that go across there. So that's all done for me. Next piece I'm going to do is really start working on the moving loads. So to do moving loads, you want to take a look at our library for a sec. So you can go and take a look by clicking on this moving load pattern icon here. It will open up my library, and you'll see we have some different moving loads added in. These are the ones I was mentioning earlier, and you can look at those patterns. Just by editing them, you can see what we're doing in there. You can add your own pattern just by clicking on Add Pattern. What I'm going to do is I'm going to use one of these rail patterns here. This is like a load here from maybe a truck. So you've got the wheel axle loading here. So I'm going to use this one. It has 3 loads, and you can see that there's going to be 1, 2, and 3 loads, and they're going to be a distance of 14 feet and 26 feet from each other. And that's the one I'll choose to use. So I'm going to say close. And this is just a library, so I don't need to call it up just yet, but I do when I want to apply it. So I go to my data entry toolbar, and I say moving loads there, and I'm going to create a moving load here. So it looks like one started for me. I'm just going to tell the program here the tag is going to be M1. You can name it whatever you want. That pattern is the M2026. That's the, HS2026. That's the one I want. Now increments. That's how often I want to apply that moving load. So I'm going to be applying it 1 foot and keep applying it 1 foot along the increment of the path I have set for my moving load. And then next piece is to tell the program if I want to go both directions. So do I want to go down a path and then turn back around and go in both ways? So I'll tell the program I do want to do that. And then next thing I want to do is define my moving load path. So first joint, second joint, third joint. So I just need to tell the program as I move across that path. So the first joint I'm going to do is going to say N46. That's this joint up in the upper left corner. And then I'm going to go to N49A. That's going to be this one over here. I'm going to the right here. And then I'm going to go to N50A. And then I'm going to go, let's see here, I'm going to keep going around the bend, and I'm going to go to N52. So I apply that. That load's going to go around that bend all the way. Now the next one I'm going to do is going to be starting up here at the upper left corner and say N49. And the next piece here is going to be N49, let's see, I'm going to do N60. And the next one I'm going to do there is going to be N53. Zoom in there, you can see a little bit, N53. And the last one there is going to be N55, which is a little hard to see, but that's that last corner there. So to verify your loading, it's best to just create a load combination and view it that way. You can view them individually or just look at them in load combination. So let's open up the load combination generator here, and I'm going to create, this one already has some dead load in it. That's just going to be my self-weight. Let's take that as my dead load. And then I'm going to apply the moving loads. So you can click on this little red arrow and you'll see that your moving loads are here, M1. You can also just type them if you remember what your label was. So my M2 is my second one, and I'm going to apply that. You can also factor it. So if, for example, that loading was not meant to be full for one rail, meant to be divided by 2, I could have applied like a half of a factor. So let's take a look at this load on the structure, because that's really the only way you can understand if you did it properly is just to visually check it. So opening up the plot options, that's on the left corner here, you'll see there's a loads tab, and you can animate the moving load. I'm going to go to the load combination I just created. I'm going to animate that. I'm going to say OK, and it will animate that. Let's see, hang on. It did not open yet. Let's move moving load, animate. There we go. And I'm going to scroll up here. So we can see the program is now showing us as the moving load moves across our screen. So what's new here is I can always speed up this and make it slower if I need it to, but I can pause it now. I'm going to pause it at a certain location, and this is load step 81. So I can kind of start moving back and forth on this to 71, to 81, keep going. If I have a specific step or load step that I want to go to, I can just type it in and push enter, and it will then get me to that 50th load step. So what that means is that the load has moved 50 increments of whatever I defined as my increment. Since I defined 1 foot as my increment, that means it's moved 50 feet along the member. So this is about 50 feet in. This one would be however much distance behind that. I think it was about 14 feet, and then the next distance behind that. So we've got all of these all located basically as we move across. So that becomes important when we run the model. Let's take a look and solve this model. I'm going to solve this one load combination. I'm going to solve the envelope combination. And in the lower right corner, you can see the program first is only stuck on the load combination 1, but it's load stepping through 308 different load steps there. So that's why you see it kind of progress is moving fast, because it's doing design on every single time it hits that. So I didn't do P delta, which is okay. I'm going to skip that for now. And it's going to show me the design results here. So if we look at the design results, we see that I do have some failures, and it's interesting to see what my failures are. So it looks like I have a failure here of 21% overstressed, and I have it at load step. If we look at the load combination, I only ran 1 load combination, but that dash number is showing me dash 223. That's the load step there that was causing that failure. So if we look at 223, for example, we'll see what was wrong with M3. That's the member maybe I'm concerned with. But it looks like I even have higher ones, like M15. If I just make a note for myself, M15 has 209. So this might be another one I want to look at. So what I can do is I can take a look through all of my failure mechanisms here. I got some real big ones, maybe 271. We'll take a look at that. And what we'll do is we'll solve, I'm going to close this. And let's go back to my loads here and take a look at what is causing this and what locations might be causing it. So if I animate it and say OK, I'm going to pause it for a second. I'm going to type the numbers in that I was worried about. So 223 was one of the ones I was concerned with. And if I click on that, I can see there, this is where this is falling, loads are falling directly on that member. So this is M3 here. This is the one that was getting caused at first. We can also type in different ones. Maybe 271 was one that was causing some problems. And we can see that that might be where we land right kind of in the structure over here. So we've got maybe some failures in here. It might be helpful for you to turn on your load your labeling or your unities or your labeling while you're in here, at least to see, so we can see that where the problems might be occurring. But the label M3, for example, was the one we were looking at. Maybe that would be helpful to see that before you show your animated shape. Excuse me, your animated loading. So it shows us a lot of information using those reporting printings and seeing how now moving those loads across that, you can now see the design results are giving us a lot more information. So it's helpful to see that load combination step. The next model I want to show you guys is going to be the geodesic dome. So let me open up a new model. I'm going to close that. I'm not going to save those changes. I'm going to just go ahead and move on with a new model. Starting from scratch, we can use what we call here the high-level generation tool, or you can say insert structure generate. So there's two ways to get into there. And if you haven't been in here before, we've got a lot of tools, general truss, we've got, if you're working with cylinders and plates, cones, these are really, really helpful ways to get started. An arc is another thing I've always used a lot in here. So if you have any shapes that are difficult, you can actually even create your own, just a standard dome with using that circular arc and rotating. But this one I'm going to try to show you here. Instead of building your own, you can just let the program do a geodesic dome. So I'm going to click on that, and I'm going to show you here how to build this. We have several options in here using this dome. So you can see you have 3 different options for the shape, and this will tell us how many faces you want to get. So let's use this one here. And then within those faces, how many subdivisions do you want? You can have 2, 3, or 4 subdivisions. So I'm going to choose the 4th, so the most complex. The radius obviously is defined here as the radius of a dome, so we can tell the program 25. And since I don't want a full circle, I'm going to tell the dome height to be 25. It's going to be landing, so it's going to be just a half dome. And we can land that dome anywhere we want for its origin. 0, 0, 0 is fine since our model is blank. And I'm going to generate members and generate plates for myself here. So I'll use maybe a steel half-inch plate, and I'm going to leave this as a hot rolled 1. And we can see that this is using a section set. This is any of the section sets we have available. But you can always change that later as a mass change. So you might just pick something and then go with that and then change it afterwards. So I'm going to say OK, and it will generate a dome for me automatically. So you can see if I toggle through here, it shows me, and look at this in isometric view, I have a dome using a wide flange beam, which is a little odd, so we might want to change that right away. But it's got a dome and it's in 3 dimensions. Now, I mentioned this several times, and it's pretty important. This is really just a template. So this gets you started, and you can manipulate this. You can change things. You can move it. You can delete half of it and modify it. Whatever you need to do for your geometry, it's just a great starting point. So don't feel locked into this as if it's a way you can't move forward on changing things. You can always modify it. One of the things you easily can do, if we mentioned that this is built off a section set called HR1, which is just an arbitrary section set that we default the program with. So you might quickly just say, hey, I know I'm not using a wide flange 8x10 on my dome, so it's easy to just jump in here and make a switch on the entire thing and tell the program, okay, let's use a 5x5. And instead of so that's going to be a tube shape. And now the program automatically changes all of those. You can also make mass changes by just double-clicking on the member and changing it. But to do it all quickly at one time, like a mass change, might be to unselect portions of it and make changes to a portion of it. So you can change this entire member by modifying it to be something specifically different. Like we can say that this one maybe will be a pipe, for example. I don't know, that would be a little strange, but we can do that and say make them all on the bottom there be pipes, and the rest of them will be tubes. So things like that. So you can make mass changes to it. I've kind of worked on a dome a little bit here. I'm going to open one I've already played around with and add some loadings and some different things. So let's open up the one I worked on and see that. It's got, just some loading on it. I put some point loads. I put some surface loads on it. And I've already applied some load combinations, some dead loads and live loads, and combined them together. And I want to try to show you here how to use the batch and the envelope solution. So if I'm going to just delete my solution file here, and so this is just starting from scratch. I'm going to go ahead and solve this model. So if we solve the model, you'll see you have a choice between the single combination, the envelope combination, and now the batch with the envelope. So that's the one I want to show you, and if you push solve, it's going to run through all of those different combinations, and then it has also the envelope with the batch there. So first thing off the bat, we can look at our joint reactions. If you click joint reactions one time, you'll see that the envelope joint reactions pops up, and that's listed right here. Now, I had mentioned we had solved the batch, so to get the single combinations of the joint reactions, I just click joint reactions one more time, and I get joint reactions. So you'll see they're slightly different. This envelope shows me a minimum and a maximum, while the joint reaction shows everything broken into combinations. So you'll see low combination 1, low combination 2, and low combination 3 listed there. So it's as easy as clicking on the results here twice in order to get the results you're looking for. So the first one is going to be always the envelope solution, and the second one is going to be based on the low combinations they're singly run as a batch. So what I would recommend is that you take a look at those envelope solutions. That's kind of a good starting point. I've always thought envelope is a really powerful tool for you to find for design. So you can sort this and find what's the worst case you've got here. So for example, M21 is giving me the highest code check I have for my model here, 883. Now that's an envelope solution, so what we'll want to do is take a look at that by itself and look at its detail report. So if we open up the single combination one more time, we pop that open, and I'm going to sort this again by using that absolute max and absolute min. And this, when you sort a batch solution, what it does is it finds the absolute max inside of that low combination. So low combination 1, that was the absolute max there. And if we wanted to look at the worst case for the model, it was low combination 3. So I'm just going to span all the way down here and find low combination 3. And I can see here, low combination 3, that's the 0.883 low unity check for that M21. I'm going to open up the detail report for that one because this is the worst case. Sometimes it's best to just pick out the worst case and take a look and make sure you agree with what's going on in this worst case of the member, see all of the information in here. So what I'd like to do is build a report for you and show you how we might use some of these detail reports to build a report. So as soon as I open up this detail report, this new button pops up here. Everybody, I don't know if you haven't been using the version yet, you see this camera button. It's a brand new button. And you'll see it on detail reports, and you'll see it sometimes on our screen. And what it means is I can take a snapshot or a camera picture of this for my report. So I'm going to click on that, and it will open up to a dialog here that is telling me it's saving this file. It names the file 3D for RISA 3D, so we know detail reports between the different programs. It tells me the member label. It tells me the low combination that got ran, and this is telling me it's a PNG, which is a picture. So, and I put it in a DOM images file. So the name of my file is called DOM. So it just created a new folder and put that images in there for me. I'm going to push save, and it goes right in there. So it's all automatic. It's really simple. Just it's nice to understand what the labeling is, but you can just basically take pictures of anything in your model that you're interested in. So I can take a detail report of another item here. This one's got not a lot of information in it, but let's take a quick informational detail report for this one, and we'll say save. And I'm going to close that. Now you can take a picture of a view of your model. So it might be important for us to know where that label of that M21 was, which is right here, M21. So that was my worst case member. I can take a picture of this showing some of my label information. This picture button here, or my camera button, is on the upper left corner. I just click it one more time, and I tell the program, do I want to do a portrait or a landscape? This probably works as a landscape, so I'm going to say landscape, and it's going to save it for me, and I just say save. And then I'm also going to do one, let's say I'm going to change one. I'm going to do it for the unity check, bending, and I'm going to color code that unity check. Let's see. This is showing me the information for my load combination 1, but I know load combination 3 was the worst case, so I'm going to switch this to be load combination 3. So that gives me some of the different colors that we were interested in seeing. I'm going to take a picture of that. and I'm going to say continue. Now it's all automated, and I did not change that first view. It said 01 model view. If I wanted to really distinguish which ones later on, like this one was called color code, I'm going to just say that so that maybe later on if I don't want to include all pictures, I don't have to, and this might help you compile things easier. So I'm going to say save, and then I've got that run there. The other thing I want to show you before we go to a full report and take a look at it is you can add your logo into your report. So if you go to your tools and you go to preferences, you'll see that there's a printing tab. And there's some details in here. If you've never come into here, you can tell the program whether you want some color in your printing, or if you want line shading, or the date and time. These are options that you can turn on and off. Date and time is kind of an interesting one. If you ever had an issue where you're compiling a report over time and you don't want to have that date stamp on it, you can turn that off. But you'll see here there's a report logo button, and that's a new button here. If you click on it, you can either choose to use no logo, you can use RISA Tech logo, or you can do a custom logo. And so that would be your company's logo. And you just browse to a location. So I have a picture of a logo of my own logo here, Deb logo, and I can just save that, and that's where my logo is located, just by default. So whenever I make a model, I'm going to have this logo by default, and I can say OK. And that way it'll always attach to anything I print. If I want to change it, I can just remove that if I don't want to use my logo. I'm going to say OK, and that's just a setting. Tools Preferences is a setting inside of my computer for any model I use. So it'll just be set it once and forget it. So I've got some pictures in there. I've got some detail reports. Let's put together a report. So I'm going to go ahead and say Printer Graphical Report. And I'm going to say Printer Report instead. It's going to jump to the Report section. And this is the new dialog that you're looking at. It used to look similar, but we added a lot of features here. So, for example, here you'll see all of the different pictures I just took. So those are going to be my detail reports and my images I just copied from the screenshots. So let's pick out a couple things and add this to maybe our global parameters are important to us. If we're looking at materials, hot rolled would be the one we care about. So hot rolled, section set, maybe hot rolled. If we want to look at results, that's kind of where we're really focused on, is going to be our design results. So let's scroll down a little bit, and I can say maybe my envelope reactions and my envelope, let's see, I want my envelope of my design results, if I can find those there. Envelope design results, hot rolled. So I've got a little bit of everything kind of compiled. I can also add all of my images into the model. I could save this as a template if I wanted to. I can add other images that I find here. If I had other images I wanted to put into the model, I could do that. The other thing, too, is that you'll notice when you now see some of your templates, since we have the batch and the envelope options, you might choose between those two. You can do all input and all output based on the batch or the envelope, and then combine them that way, too. So another thing we added is creating a PDF. So a lot of times you had to go and find your PDF printer. You can just create PDF right from here, and all of a sudden here it's going to put that in the same folder we had before, and it's RISA 3D report. We can name it whatever we need, but I'm going to say save, and now it's printing that for me. So it's running through all the pages, and you see my logo at the top of my screen, my face with my Deb rules, and you can see that as I scroll down, let me make this a little smaller, so we can see my logo pops up at every page I have here, and I'm looking at all the results I had, my hot rolls, my envelope reactions, some of the design code checks, my envelope design code checks, and that's a couple pages here at least. Then I get my detail report, and then I can see here I've got a couple detail reports that we put in. I've got an image here showing all the member labels, and then I can see the image here I included. I included using my code check. So I've got a couple different images there added in there. Now I could splice them in different locations. They didn't have to all get piled into the end. I could move them up and down maybe as they demonstrate different pieces there. But as I mentioned too, you can add PDFs too. So really If you had any kind of document that you wanted commentary in there, you could put that as well. Just print it as a PDF and put that in, or if a hand calc, you could scan it in and put it in as a PDF and put it in. So this really allows you just to open up your calculation report as a full combined collection of information for your code check. So I'm going to close that, and I'm going to move now on to RISAFloor. So I'm going to close RISA 3D. Let's shut this down. And let's see if I can pop back over to my desktop here. And I'm going to open up RISA 3D. Oops, let's see. May have to just quickly navigate and turn. Looks like I closed RISA 3D poorly here. Let me shut that down. And we're going to open up RISAFloor. Okay. So in RISAFloor, let's see here. Okay. So RISAFloor, I'm going to open up. I want to show you guys how to work with the Outriggers and the trim extend in RISAFloor. What we've got here, let's see, I've got a model that I started out, and it's got some information here, kind of just a geometry I selected, giving us a little bit of variety. And starting out, I want to show you some of the Outrigger information. So Outriggers are just like drawing in beams. If you click on a draw a member, instead of drawing a beam, it's the last option under cantilevers. And previously, you always had cantilevers. You could just extend them from the backspan, as we show here, with a number, length, and then or you can just say collinear, and it would just extend right out. But what we added here was the ability to extend it from a supporting column. So it doesn't have to be backspan in any way, and it can be of any direction, any length. So I'm going to tell the program here 4 feet in direction with an angle here of, let's say, 30 degrees. And I can choose something, I can put a wood outrigger if I wanted to. Let's choose here, I'm not going to do a tube shape. And it's going to be a A572, grade 50, and I'm going to call it a tube. And I can tell the program here to either be lateral or gravity. I'll keep it as gravity here, and I'm just going to click on the column, and you'll see I get a outrigger. It's basically a beam, a short beam drawn out of that column. It doesn't need to backspan off of any of the other ones. So previously, you would have to have had that continuously span. This is going to be fixed to the column in any direction I want. So I can also do another one on the other side. Let's say this one is going to be, we'll change the direction on this one. Let's say it's going to be 120, and same type of tube there, and I can click on that. So kind of a funny shape, but I can do really whatever I want to create that outrigger. You can draw members to the outriggers. So if I want to now create a tube shape that connects that, so it helps frame out that area there, I can just draw between those two. So you can basically, the geometry is unlimited out there. You can do whatever you want. So that's your outrigger and gives you a lot more flexibility. On the trim and extend here, this one's a great tool, I think, in RISAFloor. And because of if we see here, this is a little difficult to try to figure out how to snap these points. And I made a very easy, framing model. But a lot of times in real world, everyone knows it doesn't really look like this. You have lots of different types of framing, and you just want to make them connect. How do we just make these things connect nicely? So the extend tool really does that for you. If you click on the extend, you can click on the end of the member that you're looking to extend, and then click the member you want to extend it to. You can do that on several of these members here, and it will extend that member out to meet it. So this is a great tool in this case right down below. And the same type of problem happens here on this upper portion. I need to trim these back. For some reason, my geometry got kind of weird here. There's an opening put in, and this grid got created. I want to trim these back. So I can use the same tool, and all I have to do is click on the trim button and click on the end of the item here I want to trim, and then the crossing member. So I can do that here, click on the end of the item, and then that boundary or crossing member. So I just click on that member and back, and I can trim all of these different members. So it's quite easy to select and trim the different members I'm looking to do. Okay, so RISAFloor has these two options. Also, RISAFloor has that camera button. It's really important to point out. I showed it in RISA 3D, but that camera button is in all of the programs. You'll see it on the screen. This is really, really helpful if you wanted to label things, show the different labels of the members, and then click on your camera button and put that into your calc package. You can do any viewing that we're looking at and combine that using the detail reports, however you need to in there in RISAFloor, as well as RISAFoundation. RISAFoundation has the same type of camera button, so you'll see that floating up on the top there. Let's jump back. So that rounds out all of the new features there in RISA 3D, RISAFloor, and RISAFoundation. It shows us all the different pieces there. What's coming new here is called RISAFloor ES. This is going to be an elevated slab tool that's right around the corner from being released. So keep your eyes open. We'll be announcing that soon. But that will do the design of slab design for you, so you can get your reinforcement and be using that in RISAFloor. Then I also want to just kind of give you some pointing and some directions for additional resources. So I just had time today to give you some of the big broad stroke features, but there's lots of things that got added into the program. The release notes are the best tool to see every single thing that changed from version to version. We also have RISAnews.com. That's an article site there, a blog site that shows you articles on how to use these tools. We include videos on there as well, so if you're interested in seeing in particular one or two items there that we showed, like trim and extend, or even the printing and any of that, we have a specific article showing that, and we have some videos up there. The new features page is just as easy as typing new features on the end of that, RISA.com and new features, / new features. That shows you all of the new features with all the blogs and the videos put together. If you have specific questions, always feel free to contact us at support@RISA.com. And then, like always, we have our tutorials that walk you through how to use the entire program if you're very new and some of this has been new to you, and beyond just the new features I've shown today. And I'll hand it back to Amber. Thank you so much for your attention.